This example comes out of section 5.4, equations and graphs of trig functions. This example comes from a word problem that I did take right out of your book, mainly because it comes from some real-life electricity information from Canada, and so I can't really make up an equation that goes with it. So this is voltage equals 170 sine 120 pi times t, and it's related to current and electricity and voltage in Canada. V is voltage in volts, and t is time in seconds. So we're going to be asked to do a few things. Once again, this example is from the book, and if you want to see the extra words that go along with it, look at page 271. It'll describe a little bit more about electricity than I have here. The first question, though, is what's the period of current in Canada going from this equation? So remembering that period equals 2 pi over b. In this case, 2 pi divided by 120 pi. If you reduce that, you get a value of 1 over 60. 1 over 60 seconds, or 1/60th of a second, is how long this graph takes to do a full cycle. We'll see what that means on the graph in a second, but it does relate to the fact that the electricity in Canada is at something called 60 hertz, which just means it does 60 cycles per second, which agrees with this period that it's 1/60th of a second. Now the graph for 2 cycles will take a second to draw. Calculator will help you with this as long as you make sure you're in radians and have your windows appropriate here. The amplitude of this graph is 170, so my max is positive 170, my minimum is negative 170. We already know the period to be 1 over 60, so I've labeled these axes accordingly, 1/60th of a second, and I've done a full cycle. And so we could plot some extra points in the middle if you're asked to be more accurate about it, but this would be good enough to show that you know what's going on. Now for question C, it says if a lamp requires 120 volts to start up, how long would it take? What I would do is, you already have y1, your first equation that you're going to graph, 170 sine of 120 pi times x. y2 is just going to be 120. You'll graph those two and have a look and see where they intersect. So y equals 120 is going to be a horizontal line, looking something like that. And so we're going to find the intersection. So if you do that and graph those two equations and find your first intersection, you find that it takes approximately 0.002 seconds for this voltage to reach 120 volts, and so that's how long it would take for this lamp to start up.